Hello and welcome to Lesson 1L. I can use the segment addition and angle addition postulates. The first thing we're going to talk about is this concept of distance and length. The distance, guys, I'm going to get the hang of this one day, I promise. Let's try this again. The distance between 2 points is the length of the shortest segment that connects the points. The distance of 2 points on a number line is actually going to be the absolute value of the difference of their coordinates. We use absolute value, and guys, you need to answer this question right here. We're going to look for it in your notes. We use the absolute value symbol because absolute values force the result to be positive, and distance is always a positive value. You cannot run -2 miles. You can run 2 miles. So even if I'm going backwards on my number line, the distance between numbers is always a positive difference. So for example, I would say that if I'm looking from S to T, from point S to point T, that's from -6 to 8. If we just were to count along this number line, 2, 4, 6, 8, 10, 12, we get that that's 12. But what if I give you some horrible number like -857 and 62? In order to find the distance between 2 points using an equation, we're going to use the absolute value. So I would do the absolute value of S minus T, which would be the absolute value of -4 minus 8, which is the absolute value of 12, or 12. So no matter what, I end up with a positive distance. If we look at the distance from U to T, that's clearly 2, because by the way, guys, that number line is counting by 2. I want you all now to go through and fill in what you think US, SV, and VS are. Oh, wait, what's that? You look at SV and VS? Do you think we should get the same answer? Take a look at it. Let's take a look at the next section. Now, when we're looking at a segment, we can often break that segment up into pieces. And when we break them up into pieces, the sum of the pieces is always going to equal the whole length. In algebra or in geometry, we can say if we've got 3 points, A, B, and C, where my 3 points are collinear with B between A and C, then we can say that AB plus BC is equal to the length of AC. That's one of those no-duh postulates. Informally, we're going to say that part plus part equals whole. The points have to be collinear, and guys, now you need to write this down. The points have to be collinear because if B was not on the same line as AC, I'd get a different distance. If we had A and B, and then over here C, the length from A to C is going to be shorter than A plus B or AB plus BC. We have to be told that B is between A and C because if we had this situation, B, A, C, you can clearly see that AB plus BC in no way equals AC because AC is one of the parts, whereas BC is now the whole length. The part plus part equals whole would no longer work. So let's take a look at some examples. Here I'm told that DF is 14 and FW is 22. DW must be part plus part. 14 plus 22, which gets me 36. Now let's take a look at the next one. We've got that GB is 15 and GR is 74. I want to know how long BR is. Well, looking at this, GB is 15 and BR, that's the whole length, that's 74. 74. that means that they've given me one of my parts. I'm looking for the other part, and they've given me the whole. So in order to find the whole, it's just a simple matter of subtraction. So that we get that BR is equal to 59. We're going to use an equation to model a situation using the segment addition postulate, which is always just part plus part equals whole. And this is going to hold true no matter how ugly the numbers might look. So we always write out our equation to model the situation. Then we're going to solve our equation to find the value of the variable, and then we'll use the value of the variable to find the missing segment links if they're requested. So for example, E is between P and S. PE equals 4x plus 6, and ES equals 7x plus 15. If PS equals 120, find x and the lengths of PE and PS. Now the first thing you're always going to do, guys, this is geometry. This is a class all about shapes. You're going to draw a picture. So I'm going to draw E between PS with E in between, and I'm going to label my picture. PE is 4x plus 6, and ES is 7x plus 15. And I'm told that PS, from here to here, is 120. Well, I'm going to plug these into part plus part equals whole. PE is my part, 4x plus 6. ES is another part, 7x plus 15. And my whole is 120. Now I'm going to solve for x. I get 11x plus 21 equals 120. So I get 11x equals 99. Well, x is 9. But they don't want me to stop at x. They also want me to find PE and PS. Well, good news, they actually gave me PS in the question. That was 120. PE I find simply by plugging in my x into the equation. 4 times 9 plus 6. That's 36 plus 6, or 42 is PE. Boom. Segments with the same length are called congruent segments. And we're going to use tick marks to indicate that things are congruent, and we also use the symbol like that to integrate in between two objects to indicate that they're congruent to each other. So I want you guys right now to do this one on your own and enter your grade into the box when it prompts you. Now we're going to talk about the angle addition postulate. The angle addition postulate basically is just like the segment addition postulate, but with angles. We've got two parts adding up to a whole. They tell me in this that B is in the interior of AOC, so I'm going to draw AOC. Come on. AOC. B is in the interior, B, boom. And they tell me that the measure of AOB, that's this angle, plus the measure of BOC, that's this angle, all add up to the measure of AOC. That's my giant angle. That makes sense. Part plus part equals whole. I want you guys now to look at this example right here and see if you can find the value of FAM. FAM being this angle here. All right, let's take a look at this guy. This is another example of the angle addition postulate. Here they give the information that ABC is a straight angle. Now we learned several lessons ago that straight angles have a measurement of 180 degrees, so that will be useful. I want to find the value of x and the measures of ABD and DBC. Now I'm going to use my part plus part equals whole, the angle addition postulate, in order to help me solve this. My two parts are these two angles, ABD and DBC. So I'll say that 11x minus 12 plus 2x plus 10 equals 180. This gets me that 13x minus 2 equals 180, or 13x equals 182. I divide both sides by 13, which I don't have memorized in my head, so let's work that out. 13 goes into 18 once. I get 52. 13 goes into 52 4 times, so I get that x is 14. They don't want me to stop there, though. They want me to go ahead and find the angles, ABD and DBC. So I'm going to plug into this one first because it looks a little bit easier. 2 times 14 plus 10 gets me 28 plus 10, or 38. I get 38 degrees. Now, I could go ahead and plug into this equation with the 14 to get my answer, or I could notice that these two have to add up to 180, so I could use part plus part equals whole again. 38 plus ABD, measure of angle ABD, must equal 180. So my measure of angle ABD must be 142 degrees. So there's my 3 answers. All right, guys, take a look at the MML and we'll see you in class.